Hello, not sure if any of you are watching this, but there is a very interesting problem that I wanted to talk to you about. It's about phi of n, and you divide that by n, and you want to know about the minimizing value of this, minimal value of this particular number, phi n over n. How would you go about that? How would you go about minimizing the value of phi n over n? Here n is ranging from 0 to 1000. So if you already know about this particular function phi, you know that it counts the number of numbers less than n and relatively prime to n. So phi of n counts number of numbers less than n and co-prime to n. Co-prime to n means it must those numbers which have GCD 1 with n. By the way, this is a YouTube live, so you can actually put comments in the and I can probably respond to that as well. Okay, so the question is, you don't really need to know the exact definition of phi of n to do this. The only thing that you need to know is the formula for phi of n. So what is the formula for phi of n? It's n times 1 minus 1 over p1, 1 minus 1 over p2, up to 1 minus 1 over pk. Here, this p1, p2, pk, these are the prime factors of n. These are the prime factors of n. Okay, so the question is this, that how would you minimize this value? If you divide this by n, how would you minimize that value? So n cancels, so you have 1 minus p1 by p1, 1 minus 1 by p2, up to 1 minus 1 by pk. How would you minimize that value? p1, p2, p3, pk, these are primes, uh, prime factors of n. By the way, if you can hear me, can you put a comment? Someone put a comment here, because this is the first time I'm doing YouTube live using a encoder. So maybe you can actually tell me if something is going wrong or if you are unable to hear me. Maybe. Okay. All right. The live chat is also active here. All right. Thanks. Now, what about this? How would you minimize the value of 1 minus 1 over p1, 1 minus 1 over p2, up to 1 minus 1 over pk? How would you minimize that? So if you want to make 1 minus 1 over p1 as, if you want to make 1 minus 1 over p1 small, if you want to make 1 minus 1 over p1 small, you better make 1 by p1 as large as you can. You better make 1 by 1. Aha. Yeah, this is, I mean, this is for UG level, but it can also be used for PG level. That's all right. Exactly. As Aditya rightly points out, you can make P1 small. Make P1 small. So can any of you tell me what is the smallest prime that you can think of? What is the smallest prime that you can think of? And maybe we can use that. Maybe we can use the smallest prime to make 1 minus 1 over P1 as small as we can. So definitely the smallest prime is P1 is equal to 2 maybe, right? So 1 minus 1 over P1 is 1 minus 1 over 2, which is half itself, right? So that's the first one. That's the first thing, first piece of the puzzle. Now remember that if you multiply this particular thing, this, suppose this one is half, maybe I can pull this down. If this one is half, then we can make, this is a fraction as well. This is a fraction. Our goal is to make this as small as we can. Our goal is to make this as small as we can. Remember, multiplying by a fraction will actually make this smaller. Multiplying by a fraction will make this smaller. So we go to the next prime in the list, which is 3. The next prime in the list is 3. So P2 is 3, maybe. P2 is 3, right? So then 1 minus 1 by 3, this will be 2/3. What is the next one? The next one is in line, the prime after 3 is 5. So the next prime could be P3 could be 5, and similarly P4 could be 7. I cannot go beyond 7. Aha. It will continue to get smaller. Exactly, you're right, Aditya. But the question is, how many primes can I take? At most, how many primes can I take? So you will notice that we cannot take more than 4 primes. Why not? If you check this, this is very simple to test actually. If you multiply 2 times 3 times 5 times 7, 2 times 3 times 5 times 7, you would get 210. But if you multiply by the next prime, which is 11, you would surpass 1000. So you don't want to surpass 1000. You don't want to surpass 1000. You want to stay below 1000 because you're only testing numbers from 0 to 1000. So you cannot multiply by 11. This is not allowed. Okay. Maybe you can raise these to some powers. Maybe you can use a 2 square. You can use a 2 square. There could be multiple numbers that work. There could be multiple numbers that work. So one such number will be 2 times 3 times 5 times 7, but there are other numbers. You can raise 2 to some power or 3 to some power. So I will let you test with those. But one number that definitely works is 2 times 3 times 5 times 7, which is 210. And the phi of n over n for that is 1 minus 1 by 2, 1 minus 1 by 3, and you can just keep on multiplying this. So maybe I can just push this up a little bit more. Yes. So 1 minus 1 by 5 and 1 minus 1 by 7. So this is the crux of the matter. Now you can change the powers of 2, change the powers of 3, change the powers of 5 and 7 and get other numbers below 1000. That also works. So can any of you list all the numbers that works? All the numbers that works like this and minimizes phi n over n. You can put that list in the comment section of YouTube. And we are also starting a program called Mission 10,000. So our regular programs are obviously going on for I.S.I entrance, for Math Olympiad, for other parts of the other courses like college mathematics entrance. All those courses are going on. But for remote areas of India, for villages, for places where they do not have access to advanced mathematics or advanced education, we are now partnering with schools who work in villages, who work in slums, and we are creating this new program called Mission 10,000, where when India is in lockdown, we are still going to use our entire team to deliver great mathematics to those kids. So you can spread the word if you know some school teachers or someone who works with people like that. Feel free to spread the word and stay tuned in, and I'll see you in the next one.